All right, so this is Software-Defined Networking, Cycle 3 assignment by Clayton Boyer. All right, so what exactly is software-defined networking? It's not necessarily a new concept by any means. It's essentially virtualization of networking devices. So it's similar to uh, virtual machines with computers in that sense. It's taking the logic and the brains, the operating system essentially out of the uh, routers and switches and creating them in a software environment. Like I said, it's no different than virtualization. It's not a new concept, just a new way of implementing it with different devices. So there are three planes of software-defined networking. These planes are similar with the planes of uh, networking in general. They have the data plane. Data plane forwards information. It's what it's essentially the packets and the frames that are getting sent over, while we have the control frame that is actually telling the data plane where it needs to go. So data plane will come through, and if it doesn't know where to go, if it's not cached within the data plane, it's going to access the control plane. It's going to say, okay, what do I need to do to continue going forward with this? The control plane is stuff like routing protocols like RIP, OSPF, EIGRP, stuff like that. That's usually what is going to be in the control plane, as well as MAC address tables, IP tables, ARP tables, stuff like that. Really anything that is a table that the data plane can query to see where it needs to go. Now, the management plane is a little bit different. This is pretty much what you'd expect from management plane. It is managing your network devices. This is stuff through like SSH and Telnet, right? Any protocol that you can use to manage your device, whether it's WinRM, etc. Um, in this case, we were talking network devices, so mainly it's just going to be your SSH and your Telnet, and then console if you really wanted to count that as well. So here's some popular SDN controllers. There's quite a few of them, in fact. The most prominent one that I kind of want to bring light to is the Open Daylight. Like it says here, it's a baseline, so you can use this to create other SDN controllers, and it's open source, so you can um, build your own in the fashion that you want it to, and you don't have to go with any proprietary information, and you can make it customized to you, to your company, and the devices that you need and want. All right, so what's the difference between traditional and SDN? So traditional networking is, of course, you got your hardware, you got your router, your switch, and um, your network is based off of hardware. While you have your SDN, where your network is based off of software, right? So SDN allows for easier customization. It's all centralized, right? So you can go to one spot and you can update your router, right? You don't have to go out and buy yourself a new router. You just update it within your software. And that's something that's really great about. One second, let me make sure that okay, yeah. All right. So what's one thing that's really good about SDNs is they the biggest thing is actually the dynamic QoS. Um, an admin can allocate resources automatically to things like say you have an FTP server, SMTP, and you have video streaming. Well, depending on the time of day or the amount of resources that are needed, FTP might be a higher priority than your live streaming video cameras or something along those lines. It could be that you use live streaming or you use saving your video for like security cameras at night. So you want your quality of service to focus and your resources to focus towards being able to allocate enough information for that because who's in after I don't know, 5, 6 o'clock, right? So um, dynamic QoS allows the admins to with easier access to uh, change quality of service, and it's dynamic in some senses as well. However, you do lose out on what on hardware access. So hardware access would be like, okay, I can just I can visually plug and play with all these devices, right? Well, with the software defined networking, it's all within the software, so you have to move stuff around that way. That some may say that's a benefit, some may say that's a disbenefit, but nonetheless, that is one big difference between the two. Is one's hardware and one's software, of course. So what is SD access? This is another thing that was in the cycle reading. SD access is similar in the same sense as SDN. So SD access is centralized uh, virtualization of network. What do you call those? Network management. Not really management, but it's more of surprised I actually added on to here, but it's user access is what it is. So it's management of user access in a centralized location. I did put it here. Okay. SD access is similar to SDN and virtualization concept. Like I mentioned before, it's no different for the concept of virtualization. It's just centralized in one given spot where you can take a bunch of devices and connect them to your SD access via APIs, and it's easier to set up um, a secure environment when all your security devices are centralized, and you don't have to worry about did this user or group get the correct ACL applied, because it's all centralized. You apply it one place and it applies it to all the devices. Another good thing about it is it's less chaos for one, less security chaos. Like I mentioned before, since it's all centralized, you can do it in one spot. You don't have to go through all your devices and make sure, okay, does this group have access to SSH, etc. So that is one of the major benefits of SD access. Another good one is end-to-end segmentation of the network, so you don't have to redesign the entire structure of it, right? So with SD access, you can implement, okay, uh, I want this group or users to have access to this device, and it's that easy rather than having to um, like it says, segment and redesign your network structure to apply to that. So that is really it for the information that they cover in the book. There isn't a ton about it, but I do want to bring up. So I was asked to do a lab based on um, the Dev Cisco page. There's not a lot through here. I'll kind of walk you through it. I spent a lot of my time actually trying to learn this website and understand exactly what it does and what it's for, right? There's a lot of different options that you can use. We got the modules here. You can go through each one of these modules. Network basics. I mean, they go as deep as WebEx Teams and APIs, creating bots for it, right? The only one we really cared about was networking basics, um, and it just does exactly that. What are the basics of network? This is like CCNA 1. There's a little bit here for software-defined networks, and that's kind of the one I'm going to end up going through. There isn't much information in there, so let's go ahead and go through it really quick. So this is basically going through, okay, what is a network, right? This is all CCNA 1 stuff, basic network stuff. Um, this is the old configuration where they have the hub and all the devices connect directly into the hub, right? Um, Basic MAC address, IP address, nothing new here. Um, and this is explaining here how devices connect and how this device understands where the student computer is, right? It's going to check the switch, and if the MAC address isn't inside the switch, and if the MAC address is inside the MAC table, it's going to query, it's going to flood the network, and it's going to query the router, and the router is going to say, hey, is it inside my ARP table? And it says no, then I'm going to go ahead and flood it too. And so um, it eventually makes it over to here, and that's this whole process here. Uses ARP to broadcast ARP requests, look for the IP address on all the network devices, um, and then goes back to checking the MAC address table the for the switch, which most likely has it inside the MAC address table of this switch, and so it just finds the device it needs to go to. This is just going through the exact same thing with like a hub. And so this is just once again going in through some basics of switch and router characteristics. Um, Nothing really new here either. The only thing that is really new in this is that they do talk a little bit about software-defined networks. Nothing we really haven't gone over except for the data plane and the control plane. Um, I did go over those. Okay. Uh, and they do actually also mention Open Daylight here. I wonder where this takes us, in fact. Okay, so it's just a quick little overview and some videos for it. So, like I said, I spent a lot of time on this website. There's a lot to learn on this site. It's kind of overwhelming, to be honest. Um, the other lab that I saw was this one here. The issue with it is it goes a little deeper into Python and JSON and REST. So REST is what next cycle. So it's really difficult to do some of these exercises, and they're if I go back through the years, I'll show you the list of these here. If I type into the search button SDN, it does a quick list of all of the options here. So I mean, what five times what 20? So there's quite a few options, right? And it goes through and it's tagged with SDN. Well, if I click on this, I mean, if you can, I saw a continue lab. I mean, it's asking for Python and JSON. The next one after that, I mean, it's WebSockets, so Python, JSON, REST again, and so it's really any of these, even the basics one here. I clicked this one, continue lab, see, um, REST and JSON again, and basic proficiency with Python. So this will probably be the easiest of them all. However, it does require you to install Git, install Python. Probably easiest to do on a Linux computer due to the fact that Python's already installed. Um, but it's taking the leap and and it's assuming that your audience understands Python, right? You can't just go in and explain uh, Python and what GET requests are and the difference between GET, POST, PUT, and delete, right? It's kind of just a big leap from the class that we are currently working with. I brought this one up because it did have a little bit of information in it that I didn't add to my presentation. It goes into leaves and spines. So let's see. Yeah, it's perfect. Okay. So it goes into what ACI is and the difference between what a spine and a leaf is. So the basic definition of what a spine and a leaf actually is a spine's kind of more of the backbone, while a leaf is the distribution switches. And that is exactly used for access devices and used to aggregate leaf switches. So that's exactly what it is. It's really just backbone, core, and then access. Um, yeah, and that's really the only thing we can really get from this. I went through a little bit of this, and like I said, it gets to a point to where I mean you get into what ACI is, what ACI tenants are. Tenants are just um, within the ACI. Uh, like here, the first page here. I mean, you log in, and then the tenants are here. So these are the devices within the network. So honestly, it is extremely confusing, and there's a lot to learn. I mean, probably take me a week to understand this software. So, um, yeah, that's pretty much it. There isn't a lot to do with the labs here, unless I were to really dig deep into Python. So I think I'll call it there. If you have any questions, feel free to send me an email. Otherwise, you have a good rest.